We're on page 84. We're starting topic 16, and we're going to be solving equations that contain fractions. So we're going to first of all do the procedure for solving the equations, and then we're going to apply the procedure and solve some examples. So first thing we want to do is find the lowest common denominator to clear the fractions and solve for x. So let's just go and look at what we mean by this. The least common multiple of the denominators of a set of fractions. The least common denominator of 1 and 3 and 1/3 and 1/4 is 12. That means that the lowest number that 3 and 4 will both go into is 12. That's why it's the least common denominator. You can't put, for example, 3 and 4 do not divide into 6 and give an integer. You could say, well, I could use 24, but it's not the least one. 3 goes into 24/8, and 4 goes into 24/6. So you're looking for the least common denominator, or sometimes known as the least common multiple. So we abbreviate that as the LCD. So right over here, supposing we have the fractions 1 over x and 1 over x plus 2, we're not going to look at the numerator, so forget about the numerator. But if we look at the denominator, the least common multiple of x and x plus 2 is x times x plus 2. We have x minus 3 here and x plus 2. The lowest common denominator is x minus 3, in other words this one, and over here is that one. If we have three terms, let's say 1 over x plus 2, and 1 over 3, then we just multiply x times x plus 2 times 3. So that'll give you some idea. We need to know what the lowest common denominator is, and we're going to show lots of examples so you'll get the hang of this. Then once we determine the least common denominator, we multiply each side of the equation by this and then solve for x. And we have to reject any solution that causes the denominator of the original equation to be 0. We call this an extraneous solution. In other words, if we solve for an equation and then afterwards we find that plugging the answer in back into the original equation, the denominator is 0. Well, if the denominator is 0, then the number is undefined, and so that's not a valid solution. So we call that an extraneous solution. But we're going to see an example. So first of all, here we have an equation which involves fractions, and the lowest common multiple is for 5x, x, and x is 5x. So we're going to multiply the left side by 5x. In other words, we take this right here, multiply it by 5x. We take this, multiply it by 5x, and you can see 5x and this 5x will cancel, so I'm left with x plus 6. Here I'm going to use the distributive rule. 10x, 5 times 2. 5x times 2 is 10x divided by x is going to give me 10. And 5x times minus 1/5. The 5's will cancel, and I'll be left with minus x. So each of these steps is showed here. Here the 5 cancels. Here the x cancels, and here the 5 cancels. So I'm left with x plus 6 right here. Here 5 times 2 is 10, and here I'm just, because the 5's cancel, I'm just left with x. Okay, so when I transpose the minus x from the left to the right, over here, add it here, I get 2x. Transpose the plus 6 from the left to the right, and I get 4, and x equals 2. So now here in the manual what they do is they handle the left side of the equation down here, and they handle the right side of the equation down here. So you go back into the original equation. Let's take a look at that. Right over here, x plus 6 over 5x. So we found that x is 2. So we do 2 plus 6 over 5x, 5 times 2. And that becomes 8 over 10. And if you do this side over here, you put 2 over 2 because x is 2 minus 1/5. Instead of writing 2 over 2, I'm going to multiply the top and bottom by 10 because the lowest common multiple here is 10. Multiply top and bottom by 5 and multiply top and bottom by 2. I get 10 over 10 minus 2 over 10, which is 10 minus 2 over 10, which reduces to 8 over 10. And so since the left side equals the right side, the solution is valid. Okay, so that's our basic introduction. Now we're going to look at 3 examples on page 85. So we're going to page 85, and there are 3 examples here, 1, 2, and 3. I'm going to go into each one of those. And here, I'm going to look at the original equation, look at this denominator here. So the lowest common multiple is going to be x times x plus 5. X plus 5 is repeated here, so I only need to put it in once. So the LCD is x times x plus 5. So what I'm going to do is take this equation right here and multiply each term by x times x plus 5. And that's what I've done here. In other words, in going from line 1 to line 2, I'm going to multiply each term by x times x plus 5, x times x plus 5, and x times x plus 5. So what happens here? The x cancel, and I get x plus 5 times x plus 1. Here the x plus 5 cancel. The second term, here I'm right here, and multiply through by x times x plus 5. So the x plus 5 cancels. X times x gives me the x squared. Here the x plus 5 cancels, and I'm just left with x. So now, first times first gives me this. I combine the inner and outer to give me 6x. And the last times the last gives me plus 5. This is minus x squared here equals x. And so the x squares cancel each other. X squared minus x squared sum to 0. And the x goes over here and becomes 5x. And plus 5 becomes minus 5 here. So x is minus 1. So when I go back and I check in the original equation and replace the x with minus 1, get minus 1 plus 1 over minus 1 here, minus 1 over minus 1 plus 5. So here I have minus 1 and plus 1, which sum to 0. So 0 divided by a number is 0. Here I have minus 1 over 4, minus 1 over 4, but I have a minus in front of it, so it's plus 1 over 4, so that's a quarter. Now if I go to the right side of the equation, I have 1 over x plus 5. Okay, we go back to the right side of the equation right here. 1 over, you have to go and always put it back into the original equation. Put the minus 1 here, replace that right here, plus 5. So I have 1/4, the left side equals the right side. And so the solution x equals minus 1 is valid. Now just to go back and recapitulate what I said here, when you multiply through by the x LCD, you have no more denominator here. So that's very crucial in understanding the procedure and the methodology that we use. Okay, let's go to number 2. Look at the denominator. Here we have x squared minus 4. Here we have x plus 2. since we have this is x plus 2 and x minus 2, this factors as this can be replaced with x plus 2x minus 2, and here we have x plus 2. So you can see that the denominator must include x plus 2 and must include x minus 2. So this functions as the LCD. So what I'm going to do again is multiply both sides, going from line 1 to line 2. Okay, I'm going to multiply both sides of the equation by x squared minus 4. So I take the 1, multiply it by x squared minus 4, take the 12 over x squared minus 4, which is right here, multiply it by the x squared minus 4, and I'm going to, instead of writing x squared minus 4, I'm going to write x plus 2x minus 2 times the 3x plus 2, so that I can cancel the x plus 2 portion of this right here. So in doing so, we have cleared the fraction. So we can solve for x. There's no more denominator. Here I have x squared minus 4 times 1, which is this. I have minus 12, which is right here with a minus sign here. And here I have 3 times x minus 2. So this is x squared minus 4 minus 12, 3x minus 6 by the distributive rule. Now what I'm going to do, this x squared is this x squared. I have minus 4 and minus 12 is minus 16. I bring this over plus 6, so minus 16 plus 6 gives me minus 10, and I'm going to transpose this from the left to the right, and I get minus 3x. So this equals 0. So now I'm going to factor this as x minus 5x plus 2. The inner times the inner gives me x squared. I have minus 5x plus 2x, inner and outer, combined to be minus 3x, and the minus 5 times the plus 2 gives me the minus 10. So this is the correct factor. From this, I can make x minus 5 equal to 0, in which case x is 5, x plus 2 equals 0, x is minus 2. Now, turns out that you can only use one of these solutions, because if you put minus 2 back into the original equation, this becomes 4 minus 4, which is 0, and the denominator is undefined. The fraction is undefined if the denominator is 0. So if x is minus 2, I get 4 minus 4, which is 0. 12 over 0 is undefined. Similarly, if x is minus 2 over here, this is undefined because minus 2 plus 2 gives me 0. I cannot have the denominator of a fraction equal 0 because then it's undefined. So we say that minus 2 is an extraneous solution. So the only solution is 5. Now I go back into the original equation. The left side is this. And x squared is 25 minus 4, which is 21. Instead of 1, I write 21 over 21 minus 12 over 21, which is 21 minus 12, which comes out to be 9 over 21, which reduces to 3 over 7. And the left side of the equation is x plus 2, x is 5, 5 plus 2 is 7, we get 3 over 7. The left side equals the right side. So the last example is an application, and here we're told that the sum of a number and 6 times its reciprocal is 11 over 2. Find the number. So here we have let x equal the number, and this means x over 1. Then the reciprocal is we just turn it upside down. The 1 goes up here, and this goes down here. So what we know is x plus 6 times its reciprocal. So here's the reciprocal right here. So x plus 6 over x equals 11 over 2. You can see that we have x on the denominator here and 2 here. So the lowest common denominator is 2x. Now, in going from line 1, here's line 1 to line 2, I'm going to multiply each term by 2x. So 2x times x gives me 2x squared. Here, 2x times x gives me 2x squared. Now I'm going to multiply 2x times 6 over x. So the x's cancel and I get 12. And 2x times 11 over 2. The 2's cancel and I get 11x. So you see we've cleared the fraction and we can now solve for x. Here we transpose this from the right to the left. We get minus 11x. The 12 stays on the right side and we factor this. And you can see that because this is minus and this is plus, both of these have to be negative. We have a minus 3x inner and a minus 8x outer. They sum to minus 11x. And we get two solutions. If 2x minus 3 equals 0, we get x equals 3/2, and x can equal 4 also. So both solutions are correct. Here I've put 3/2 into the left side. I've got 6 over 3/2, which is the same as 6 multiplied by 2/3. So I just flipped this over and multiplied 6 divided by 3/2 is 6 multiplied by its reciprocal 2/3. So this becomes 6 times 2 is 12 over 3, which is 4. 4 is 8 over 2, so I can sum the 8 and the 3 and get 11 over 2 because I want to multiply the top and bottom by 2 here to get 8 over 2. This is 4 over 1. Multiply the top by 2, I get 8. Multiply the bottom by 2, and I get 2. Get 11 over 2. The left side of the equation is 11/2 here. I have to always go back into the original equation. Now if I check x equals 4, the left side is 4 plus 6 over 4. This is 8 over 2 plus 3 over 2. This reduces to 3 over 2, so it's 11 over 2. And we know the right side is 11 over 2. So both of these solutions are valid. So this completes our discussion on Intro to Equations Involving Fractions, topic 16, pages 84 and 85.